Last one, example 8, applications. I feel like being able to use the stuff we're learning is one of the most important reasons that we're using it or learning it. So let's look at this one. Suppose a new car loses a fixed proportion of its value every year. Its value after t years is value of time t equals the initial value times 1 minus r to the t power, where v sub 0 is its initial value and r is the proportion of yearly loss. If the car was bought initially for 25,000 and loses 20% of its value every year, after how many years will it only be worth 10,000? This is a very interesting problem for me right now because I actually just bought a new car, a brand new 2020 Subaru, because it had an interest rate of 0.9% and I couldn't pass that up, and I've been wanting a new car for a while. So let's plug in what we know here and see what we can figure out. So our formula is v of t equals our initial value, which is 25,000. If you'd rather not work with lots of zeros, we can honestly just work with thousands. So like we can just say, we're going to say 25 is in thousands, and then this, as long as we use the 10 in thousands, then it'll work out just right. Now for this part, we have 1 minus r, so r is 0.2. And t is what we're trying to solve for. We want to find the exponent, which is where we need to use logarithms most likely to figure this out. So the only thing I haven't plugged into this formula was the 10 at the beginning. So the value of the car after so many years is going to be 10,000. And that was with an initial value of about 25,000. That's about what I pay for my car. And then it's going to lose about 20% per year. Now, I don't know if that is accurate for mine. I am curious now. We'll have to do some research. Okay, the first step we need to do is realize that the base of our exponential is kind of a weird number. The base of our exponential is 1 minus 0.2, so it's a 0.8. That means that since this number is less than 1, this is going to be exponential decay. It's going downward, which is what we would expect, right? The other thing we learned today from solving is that we need to get the base and the exponent by itself. So we need this 25 out of the way. The first thing we're going to do then is divide both sides by 25 so that we can get rid of the coefficient here. And then, yeah, we have a fraction over here, but we can deal with it. Okay, I'm going to go ahead and just switch sides. I guess I don't need to. It just feels better that way, but maybe I should just keep going. Okay, so 10/25ths, if I'd like to, I can reduce this fraction. It reduces to 2/5. So 2/5 is equal to 0.8 to the t power. I'm going to go ahead and take the log of both sides. It doesn't matter if I do log base 10 or natural log because there's no 10 or e in this problem. So it makes no difference whatsoever. I'm going to go ahead and use our common log base 10. Do the log of each side. So log base 10 of 0.8 to the t power. So then here's what we learned to do today. I'm going to go ahead and move the t out to the front. So we get t times the log of 0.8. And that equals our log of, if you'd rather, you can just change this to a decimal as well. There's no point in having one side be a decimal and one side be a fraction, but it really doesn't matter. So 2/5 is the same thing as 0.04. So then I divide both sides by log of 0.8 because I'm trying to get t by itself. Okay, so now we know what t is. T is the log of 0.8 divided by the log of 0.4. Well, that's not a very good answer to this question to say, hey, my car is going to be down to $10,000 in value after this much time. Log 0.8 divided by log 0.4. Yeah, who says that? Nobody. So we're going to put that in a calculator and find out that t is approximately equal to 4.1 years. So if I have a 6-year loan, 72 months on my car, and I make my first payment in May, that means before my car is even paid off, it's going to have dropped $15,000 in value. Cars are strange that way. Okay, hopefully that was interesting. Tuning out. Good luck with section 4.3.